quite a lot today, if you can. Okay. So what we did the other day, you see, this is our chart for this chart. Okay. So we introduced the second order differential equation, linear differential equation. That's a general format. Okay, that's the one. Make sure that the coefficient of y double prime must be 1. If it's not, going to make it 1. Dx is always the coefficient of the y prime and qx coefficient of the y. So if this r of x is just a continuous function, can be any function. If r of x is equal to the 0, we're going to have associated equation, that's the one. This by itself is going to be interesting problem. So this is going to be homogeneous one. So that's a homogeneous second order linear differential equation. What we did the other day, we planned what is going to be the general solution of this type of equations. So what we did, we divided in two parts. One part is the homogeneous one. The general solution of this homogeneous one, we call it YC. Okay. Then we prove that if you have a general solution of the homogeneous one, and you can find a particular solution of the first one, we call it YP, then YC plus YP would be general solution of the homogeneous of the second order linear differential equation. Okay, so we did prove everything that we need. So we are going to investigate how we're going to find the YC and the YP. So we did some work on the YC. Okay, so we changed it to the homogeneous one. That is the case. So we focus on how we're going to find this YC, the general solution of homogeneous one. And we proved a theorem that if Y1 and Y2 and Y2 happen to be two given solution, then any linear combination. Linear combination means, you multiply the first one by a constant, added to the second one. Any linear combination of that Y1 and Y2 is going to be also the solution of the equation. Then we prove more. We prove that you see if this Y1 and Y2 would satisfy a special condition, or if they are going to be independent in the language of the linear algebra, this would be any solution, okay? Any solution of the equation can be written in this format. Because there is a guarantee that you can find the C1 and C2 that satisfy this condition. We proved it, okay? In the course of the proof, we arrive at that what condition that we need. You see, we guarantee that Y1 and Y2 would generate all the solution of the equation. They must satisfy this condition. In terms of this matrix, we call it Wronskian, okay? And then we prove that if this Wronskian is not going to be equal to the 0, then it's a guarantee that the Y1 and the Y2 are going to be independent vectors, okay? And eventually Y equal to the C1, Y1 plus C2, Y2 are going to be your solution of the equation. Okay, so we plan everything. Now the question is going to be how we're going to find it. Okay, how we're going to find that Y1 and Y2 so that they are going to be satisfying the Wronskian conditions, and then you'll be able to get your solution. So what we're going to do, we are going to start with one method first. This method would help us. Okay, would help us eventually to find the Y1 and Y2. What is this method? This method is if a homogeneous, we focus, we say with the homogeneous. If a homogeneous second order differential equation is given to this one, and if you know one of the solution, okay, one of the solution, how do you know it? They may give you this solution most of the time, or you may guess. If it's going to be easy, we can find it. If it's going to be power of x, you can easily find it. E to the x, sine x, cosine x, not easy. But this one solution would be given to you. If one solution would be given to you, then we can use a special substitution to reduce this equation. You see the order is second. We reduce it to a new equation of the first order. Then we can solve that equation and find the second solution that we're going to interested in. Okay, so if y1 is given to you, or if you give me y1, I am going to find the y2 for you. Something extra is this y2 and the y1 together, then it satisfies the Wronskian condition. So automatically I can get the yc because it's cy1 plus cy2. Okay, so this is plan number one. Okay, so we are going to call it reduction of the order method, and it's going to be, it would help us to be able to find a general method in order to get the both solution together. But this is very popular. There is no restriction on this one. We can use it all the time. Okay, so we are going to start with this one. I'm going to prove it for you. There is a formula, but the proof is nice to see it. But you can use the formula right away and get the result. Okay, but the proof is going to be interesting. Okay, so we are staying with the homogeneous equation. Okay, to get the yc, but you have to go through this. So that's a 4.2. 4.2, we call it reduction of the ordered method, or the idea is finding a second solution when one of them is given to you. Okay, so construction, it's going to be construction, a second solution. Okay, a second solution from a given one, a known one, a known solution. Okay, constructing a second solution from a known solution, of course, for a second order homogeneous linear differential equation. So we can use it for this type of equation only, okay? Differential equation. But in short, we call it reduction of order method, okay? We refer to it as a reduction of order method. Because to find it, your differential equation is going to be, you change it to differential equation of a first order, and then you'll be able to do it. Okay, it's very nice, nice proof. You see it because you may do this type of proof for some other things. Okay, it's nice. Okay, there you are. So what's the problem? The problem is you give me one of these homogeneous equations. So suppose we have one solution. Suppose y1, which is of course a function of x, is going to be a given solution of homogeneous differential equation. Okay, is going to be a non-zero solution of the equation. This is the equation, homogeneous one. Y double prime plus px y prime plus 2x y equal to this. Okay, so this is the known one. Y1 is given. We want to find the y2. That's the idea. So what we'd like to do, we'd like to find. Okay. So we want to find, that's the target. We want to find a second solution. Find a second solution for a function. A function, it's a standard to call this function v. V equal to the v of x. In your book, I think I call it u, such that it's more popular to use u. So the proposal is this one. I'm going to find the function v such that this new function such that y2 equal to the v times y1. Remember, y1 is already given to you. So suggestion is I'm going to find the y I'm going to find the function v so that this y2 equal to the vy1 is going to be a solution of a differential equation. Is the second solution. Is the second solution. Okay, second solution of the equation. So that's a suggestion. At the end of the course, we do the same thing for the system of the equations. Okay, this is it. So we have to find this. Okay, you have to find the function v. So what we're going to do is we assume that this is the solution of the equation. You know that if it is going to be solution of the equation, it must satisfy the equation. What you have to do, substitute here. Okay, substitute this new function in this. Okay, in the equation they're going to have. In order to do it, you need to find the first derivative and the second derivative. Okay, so work on the derivative. Note that you want to force it to be solution of our equation. That's it. So this is it. The function is y2 equal to the dy1. Okay. Differentiate it to find the first derivative. What is going to be y2 prime? Y2 prime, you have to use the product rule. Derivative of the first times second, second first. All of them are functions. So it's going to be derivative of the first one, it's going to be v prime times y1 plus derivative of the second times first is going to be v y1 prime. This is going to be, okay, the first derivative. Any question? And you also need the second derivative. Okay, find the second derivative. Carefully find the second derivative. Repeat it again. So that's going to be y2 double prime. Y2 double prime. You have to apply the product rule here. So that's a v prime. It's going to be v double prime of the first times second plus derivative of the second times first. Going to be v prime. Okay, y1 prime. That's when you apply the derivative of the, okay, find the derivative of this function. You have another one, the second one. You continue, so that give you plus v prime, derivative of the first times second, plus the derivative of the second times first, which is going to be v y1 double prime. Okay, I just differentiate it. You can simplify this y2 a little bit. You see you have two like terms. You have the v prime y1 prime and the v prime y1 prime. So these two together, it's going to be twice. So that gives you y2 double prime. Okay, y2 double prime would divide, would be v double prime y1 plus twice. Okay, twice of the v prime y1 prime and plus v y1 double prime. Okay, so that is going to be y2 double prime. Any question? So if you want, if y2, you see, it's got to be the solution of your equation, it must satisfy the equation. So what we're going to do, you are going to substitute y2 prime and y2 double prime in what? In the equation. So substitute to see what I'm going to do. Okay. So I'm just explaining that we assume that the y2 is going to be the solution of the equation. Okay. So y2 is the solution of the equation, differential equation of the equation. If what? If it satisfies the equation. Satisfy the equation means you should have y2 prime, y2 double prime, plus px times y2 prime, plus qx times y2 equal to the 0. Okay, because this is the solution of the equation, so it satisfies the equation. Now carefully substitute. Okay, substitute for all of them. You already got it. This is y2 double prime. Substitute for y2. You're going to get this This is going to be y v double prime, y1 plus 2 v prime, y1 prime plus v y1 double prime. So that is so far for the y2 double prime. Okay. So continue. The next step is going to be what? The next step is going to be px y2 double prime. So it's going to be plus px times the y2 double prime. This is y2 double prime. So the y2 double prime is what? Is v prime y1 plus v y1 prime. That is going to be px times. Okay? Then you have a qx times of y2. So it's going to be plus qx times y2. Remember the y2 is what? Y2 is vy1. Vy1. And this is supposed to be equal to this. Okay, I just substitute. Y2 is the solution of the equation, so it must satisfy the equation. Now try to simplify it. The way we're going to simplify it is, I'm going to put those y1s together. Okay, I can multiply this inside to repeat it or just do it as is. Okay, let's put those y1s together. Look at the y1s that we have. So I have here, okay. So what we have, I have v y1 double prime here. Okay, this is going to be one of them. And then I have, look at this. I have the px times v y prime here. Then I have the qx v y1. Look at the term that I underline over here. All of them are going to have the v, okay? So I can factor out the v of these, okay? If I factor out the v, what's going to be the leftover? The leftover is going to be y1 double prime, then plus px y1 prime, px y1 prime, what? Qx, okay, qx y1. What is inside the parentheses? Do you have anything about this one?
It's equal to 0.
Equal to what?
0.
0. Because y1 is the solution of the equation, remember? Y1 is, so this would be 0, everything would disappear. Okay, what's going to be the leftover now? The leftover are going to be the following, okay? The leftover is going to be plus, let's write it down. We get the v double prime y1 plus 2 v prime y1 prime, okay, plus p of x v prime y1 equal to this. Remember, you should find a formula, an equation. You are looking for v. Okay, we're looking for v to get these numbers. Okay, so this first part would be 0 because y1 is the solution of your equation. Let's see what we can do about the second part. You see the second part? If you look at this second part, y1 is given to you, know it. y1 double prime is known, p of x is known, v1 is known. The unknown of this problem is v, because this is the v that you are going to get. There is a v prime and the v prime here. So let's simplify it a little bit and then try to solve it. That would give us the formula. So this is what we have so far. So we get the v double prime. Okay, that's a v double prime y1. So there is a v prime as a factor. I'm going to put it out. So that give me 2y1. Okay. I'm going to take out the v prime. So there's going to be 2y1 prime and the plus px. Okay, px times y1 times it by what? Times it by v prime equal to the 0. Okay, any question? Remember, we are looking for v. Any suggestion? How are we going to solve this differential equation for v?
For new v. For
Bring in.
substitution.
So it's a kind of separable variable type.
Px, qx.
Yeah, that's because you have only V double prime and the V prime. There is no constant there. So I'm going to move one of them to the other side. So kind of separable variable, the V. So move the other one to the other side. That give you 2y1 prime plus px y1, okay, times V prime. Look at this. And kind of separable variable. So you can put those V's together and the rest together. So divide by V prime, because everything on the other side is known. So that give you what? That give you V double prime. V double prime divided by V is equal to what? Is equal to the negative 2y1 prime plus px times the y1. So this is a kind of separable equation, if you like. That you are going to have. Okay, this is, I'm sorry, that's a V prime. It's a V prime, and what I did is I have an extra y1 here. Okay, I want to do separable variable. So I put the V and the V prime together. So the leftover, there was a y1 here. So I have to divide on the other side by y1. Okay, remember separable variable, we put one of the variable and the derivative of one side, everything else on the other side. So we put everything that we have, see V double prime and the V prime on one side, and I divide by y1 so that I get this one over here. Okay, it's separable variable. Nicely can be solved. You can simplify it a little bit. Okay, you can break this one because you want to integrate it to make it easier. So what we can do is we can rewrite it as this, to take care of that V1, break it. Okay, break it into the negative 2y1 prime over y1. There's a negative sign here, minus, that give you px y1 over y1. So this y1 and y1 will cancel out. Okay. So what I'm going to have is on the left, I have v double prime of v prime, all of them are function of x. And on the right, I have 2y1 prime over y1 minus bx. Okay, going to integrate it. Okay, it's separable variable. Separable variable, integrate respect to the x on both sides of the equation. That would give you the function if you are interested in. Any question? So we go to the next page and we find it. There's the formula. You can memorize the formula. And the proof is nice. Okay, you can use it in different places. Interested in this type of ideas. Okay, integrate. We have v double prime over v prime on one side, dx. Okay, and on the other side, we have integral of what? Negative 2y1 prime over y1 minus p of x. Okay, all d of x. So I integrate, both sides. Any suggestion for the left side? What's the integral of v double prime over v prime? ln of what? V prime, yes, v prime. Because the of v prime is on the top. Okay, it's v prime u if you like. So this is going to be ln of v prime, or the absolute value of v prime. We're going to change it. We don't need that. Equal to anything to the right.
Negative 2 y1.
First one, negative 2 ln of y1. Okay, and we can't do anything about the other parts because we don't have the px. So it's going to be minus integral of px dx. Px dx. Okay, so we are almost there to find the v prime. And now, if you like to make it better, so I'm going to get rid of this ln function. Okay, so you know that you can e all of them to get the numbers. And I'm going to move this negative 2 up first. Okay, so then I do the job, or I can do it later. It doesn't matter. So it's going to be ln of v prime is equal to the ln of let's say y1 to the -2. Okay, y1 to the -2, and this is going to be integral of px dx. Okay. Now we can use change it to the exponential form. So if change it to exponential form would be what? V prime equal to e to the ln of y1 to the -2 minus integral of px dx. Break the term to the right with the formula. V prime would be, remember the product. This would be e to the ln of y1 to the -2 times e to the negative px dx. Okay, what's the first one? E to the ln of y1 to the -2 would be y1 to the -2. So it's going to be v prime equal to y1 to the -2 times that by what? Times that by e to the integral of negative x dx. Okay, change the y1 to the -2 as, this is it, as 1 over y1 squared e to the negative px dx. Okay, this is going to be v prime, but we are looking for v. So integrate it. Okay, that give me the formula. It's going to be v. Make sure you write it down correctly. Okay, v equal to integral of 1 over y1 squared, okay, times e to the negative integral of px dx, then everything dx. That's it. So we can find the v using, because the y1 would be given to you. You have the px from the equation. Make sure that you know y double prime coefficient must be 1. This is where you're going to miss it. This integral must be easily done. If it's going to be complicated, probably you miss that. Integration by parts is going to be around quite a lot for this one. Yes.
In this class, will we ever do double or triple integrals?
Oh, no. Because this is, we're working with the function, we work on the ordinary differential equation. ODE, we call it. If you do the function of several variables, then the derivative would be partial derivatives. Then we have PDE, partial differential equation. Okay, that would be something different. Okay, so we are not done. So this is V. As soon as you find the V, y2, remember, y2 equal to the v y1 is going to be, is the second solution. Is the second solution. Later on, we do it for the system of the equation, but we write down a kind of matrix form. And that's why I prove it. I prove it so that when we get to that part, you are familiar with whatever we did, and quickly we can get rid of, do the job. Okay, but the bonus is good. Remember that you have now y1 and the y2, so we can write the yc c y1 plus c y2. Remember, you need an extra condition. The extra condition, they must be independent. So you have to check the run scan. So we're going to check the run scan, prove it for you. So you are done. You know that if you pick y2 from this method, automatically y1 and the y2 would be independent. And you don't have to worry about it. Quickly write c y1 plus c. It would be fun to prove the run scan, okay? So let's do the run scan. So note that, remember the formula for the run scan, you can write on the matrix form, or the one that is suggested the other day is going to be y1 prime, y2 minus y1, y2 prime. Okay, that's going to be the run scan, or in matrix form. And now let's bring you have to bring those, the derivative that we're going to have. So in this case, y1 prime is just a y1 prime. Okay, that's going to be y1 prime. The y2 is vy1 minus y1. You have to find the derivative of y2 prime. Okay. If you just go back and check the derivative of y2 prime, we can get it from here. Okay, remember it was a product, term derivative of the first times second. Okay, second first. And if you put them together, they would nicely simplify. So that give you y1 prime, y1, and this is going to be y1 b prime, y1, and this is going to be plus y1 b, okay, y1 prime. Get these numbers, okay. That was the, let's make sure we get it right, okay. So these first two, we have these two would cancel out, okay, that's it. We then missed the sign. The negative sign here somewhere. It should have this, the negative y1 prime by prime.
Oh, it's the, when you did the derivative, it's, that should be, in the parentheses, should be a plus sign.
Which one, this one?
Yeah, it should be a plus.
Oh, yes, thank you, very good. The product rule. Okay, so you missed that one, so that's a negative, okay, very good. So these two would cancel out. Okay, this would cancel out, the middle one would be what? The middle one would be negative y1 squared times the v prime, okay? Now what's going to be the v prime? See, this is it. For the v prime, you drop the integral, okay? You drop the integral because the derivative of the antiderivative would be just a function. So it's going to be, that's it. So it's going to be just, you already got the v prime here, if you don't like to see the v prime here. So you have 1 over y1 squared e to the negative integral of px dx. Okay, so these two would be canceled out. Okay, I just substitute, there is no v prime. I just substitute for the v prime, okay, for the v prime. These two will cancel out. So the final answer is going to be what? The final answer would be negative e to the negative integral of the px dx. You know that exponential function never zero. So this is always a non-zero number. Yes.
There's a negative in front of the y1 squared. Does that cancel out with the 1 in front of the e?
Yeah, that's going to be.
So it'll be positive e.
No, it's not positive.
Oh, right.
No, it's not positive. Because the y1 would cancel, okay? It's going to be a non-zero number. Okay, so the Wronskian is so nicely proved. It's one of the problems in your book. They ask you to prove that the Wronskian of this solution is not equal to the zero. Okay, so there you are. Wronskian is not equal to the zero. So the conclusion is going to be, therefore, y equal to the what? Y equal to the C1, Y1. And C2, Y2 is the general solution. Okay. It's going to be the general solution of that equation that you start with. So automatically, the solution that you got from here, with the given one that would be given to you, is going to be linearly independent. So quickly you can write, you don't have to prove it. You can write the general solution as a C1, Y1 plus C2, Y2 to get this one. Any question? We need this one. There is another theorem for finding the general solution. We need this one to be able to get it. Yes.
Can you just go back to the last page real quick?
Last page. Yes. Okay, so you got the second solution from here. Because the first solution, in some problems you can guess what is going to be the first solution. Then you can pick it out, you pick the second one. We'll do an example. Okay, there are a couple of very famous examples. You've got to be patient to get through it. Again, I repeat, differential integration by parts, especially like, x squared, a power of x times ln x. That would be very popular. All of them, the ln x is very easy, you can do it. But you are going to have the sine and a cosine. You should be able to do the sine and cosine by it's a popular method that we talk. Okay, and I give you one of them to check. Okay, and that's it. We give you one question on this quiz and the next test. We give you one y1 and we ask you to find the y2. Automatically, you know what method are going to use because there is no other way to do it. Okay, so your job is make sure you remember this formula. That's it. You can use the formula, and this is it. 1 over y1 squared e to the, as usual, we identify the px first. We go for the integral px, find e to the, then you bring it up to take the integral. The only thing that you may miss is p of x. When you find the p of x, coefficient of the y double prime must be 1. All those nice, famous equations that you have in differential equation, you can have the, for this problem, you have the Euler one, if we have the one of them we call it Euler-Cauchy equation. The other one we call it Bessel equations. All of them, coefficient of the x squared is x squared x. If you miss it, this integral would be very complicated. You just go back and mention it. Okay, there you are. I'll give you 2 examples. Okay, the second one is very famous one, just to get to know this type of thing. Okay. So you shouldn't have any difficulty. You have 2 on the practice quiz that are posted for you. You can check it right away. Okay. So there you are. The example is this is it. It's given to the function. Okay, the function. The first solution are very easy. Sometimes you can find yourself. X squared e to the x sine x. But it would be given. The function y1 equal to the x is a solution. When they say is a solution, you don't have to check it. But sometimes we say check first, remember. Is a solution of this equation. The equation is x squared y double prime plus x y prime minus y equal to 0. This type of equation, you see x squared y double prime, x to first power y prime. This type of equation, we refer to them as a Euler-Cauchy equation. And we are going to talk about it for you in general in future. But no, you don't know it, so we can use it as an example. Okay, so the function y1 to the x is the solution of this. We would like you to find the second solution. Okay, find the general solution. Find the general solution. General solution of the equation. There you are. That's it. You know that this is homogeneous equation. If you have 2 solutions, y1 and y2, linear combination is your result. So y1 is given to you, so you must know that you have to use the reduction of order method in order to find the y2. Okay, so the solution is going to be, so y1 is given, is equal to the x. Okay, you need the y2. So the method for y2 is the one that we talk about it. Y2 would be v y1. Your v would come from this formula. Integral of 1 over y1 squared e to the negative integral of px dx, everything dx. Okay, this is your plan. Now go for it. The first thing to do is check to see if the coefficient of the y double prime is 1. It's not. So what you do is you divide both sides by x squared. Make sure you do it first. Okay, to be able to identify the px. So if you divide, that gives you y double prime plus 1 over x, y prime minus 1 over x squared y equal to 0. Identify the px. First thing to do is find the px. Any question? Px is the coefficient of y prime when this y prime, coefficient of y prime is 1. So that's it. You have the px. Px is 1 over x. Start working on this, okay? Integral of px dx. You are going to work on this, okay? So get the integral of the px dx. It's going to be 1 over x dx. It's going to be ln x, no constancy, remember, because these are not the solution. Okay, it's just integrating factor. So this is going to be the case. I'll go for the e to the negative integral of a px dx. Remember, there's a negative sign here. It's going to be e to the negative ln x. It's going to be e to the, move the negative sign up. Okay, so that give you e to the ln of 1 over x. So the result would be 1 over x. This is the inside integral. Any question? So we simplify this one. I'll go back to the v and substitute. With the v is integral of 1 over y1 squared. Okay, e to the negative integral of a px dx. Then everything dx. So it's going to be integral of 1 over y1. y1 is x, okay? y1 is x, so y1 squared would be x squared. X squared, and this e part, you already simplify it. Okay, so it's going to be 1 over x. 1 over x dx. So easy to find. Okay, 1x cubed. You will move it up. It's going to be x to the negative 3 dx. So it's going to be x to the negative 2 over negative 2. Okay, which is going to be equal to the negative 1 over 2x squared. So v is equal to the negative 1 over 2x squared. Any question? No constancy. Now that's a v, we are ready to give you y2. So the second solution, y2 is equal to the v times y1. So v is negative 1 over 2x squared, and the y1 is x. So simplify 1x, so that gives negative 1 over 2x. So the second solution of your equation is going to be negative 1 over 2x. That's it. This is the second solution, and the y1 is one solution. First solution, and we already proved that they are independent. So the general solution of the equation would be what? General solution of the equation would be c1y1 plus c2y2. Then you just substitute. Okay, so it's going to be c1x plus c2 times negative 1 over 2x. You can consider negative 1/2 as x as a constant. So you can declare that your solution is c1x plus c2 over x. So this would be the option. Very good. Any question? And you don't have to check that around. Yes.
How does the 2 in the denominator cancel out?
You see, it's negative. It's going to be. See, that's 1 over 2x is like 1/2 times 1 over x. So this is going to be 1/2 times c. We call it c. You know, it's optional. If you want to have something nice, because the coefficient is going to be constant. Okay. So the coefficient is 1/2. It's going to be 1/2 of a c2. 1/2 the c2. You call it c2. That gives you the final. Okay. Any question? So again, make sure your px, the danger is only the px when you find it. When you find the px, the coefficient of at y double prime must be 1. Any question? There's a famous one, and I'm going to do it for you. You will see this problem in a couple of versions. Okay, just be patient and be ready for it. You see a version of this one somewhere. Okay. We call it the Bessel equation. We come back to it again. We work on this homogeneous one. Example. It's a Bessel equation. Of course, you know, it's a homogeneous one. So this is it. If y1 equal to x to the negative half sin x. It's a characteristic of this equation that the solution will be of this type. You can write it as a 1 over radical x. So if y1 equal to the x to the negative 1/2 x is a solution, of this equation. Again, look at the equation, x squared y double prime plus x y prime plus x squared minus a quarter times y equal to 0. X is a positive number. If this is going to be the case, we wanted to find the general solution. Okay, find the general solution. General solution. Solution of the equation. Bessel equation going to be different format. Okay, this number a quarter, you can change it various form, and you will see it from time to time. It's not easy to solve this equation directly. Okay, we have various form. Later on, this is homogeneous. I'm going to put something on the other side, x squared x cubed, and then we ask you to solve it. It's going to be a kind of a challenging problem. So we wanted to be aware of this group, okay? So again, patiently get the formula. And that's it, you know it, you have one solution, homogeneous. So in order to get the second one, the option is going to be reduction of the order formula, okay? So solution, remind yourself that I have the y1, which is x to the negative half sine x. It's a homogeneous equation, so I need only to find y2. Okay, I need to find the y2. My suggestion is reduction order formula, EY1. Okay, and you know the V, you can repeat it. Integral of 1 over y1 squared e to the negative integral. It's not optional, just remind you. This is your first. Okay, so you start with the equation. Look at the equation that you have. Again, it's x squared y double prime, xy prime, plus x squared minus a quarter times y equal to 0. Identify the px. You have to divide by x squared again. You divide by x squared. By x squared, so the result is going to be what? You get y double prime plus, again, this would be 1 over x y prime. The rest are not going to be important. I'm not going to use it. You can divide it. If you divide that, give you 1 minus 1 over 4 x squared, y is equal to this. We are going to be concerning with the px. Px coefficient of the y prime. So the px is going to be equal to the 1 over x. Any questions? Go for the procedure, integral of a px, e to the px dx. So we go with the integral of a px dx. Is going to be 1 over x dx. Okay, again, ln x. Consider the e part. So you are interested in the e to the negative integral of a px dx. It's going to be e to the negative ln x. It's going to be e to the ln of 1 over x. And the result will be 1 over x. That's e part. You pay attention when you simplify it. I'll go and form the v. So what is the v? The v is integral of 1 over y1 squared. I repeat it, you don't have to. Px dx, everything dx. Substitute. So the situation is y1 is y1, you got to be careful. y1 is what? X to the negative half sine x. That is going to be your y1, then you square it. Okay, you square it and times it by what? Times it by 1 over x. 1 over x. 1 over x, then dx. That is the situation I'm going to have. Okay, now we have to simplify it. Now, how are we going to simplify it? You can, you see, you square it first. It's going to be integral of 1 over x to the negative half. You square it. What's going to be the result? Negative 1. When you square, you multiply the exponent together. So that gives x to the negative 1. Okay, that gives you x to the negative 1. And this is going to be what? This is going to be sine square of x. Okay, so this is the case. Then you have to multiply by 1 over x, 1 over x dx. Now we can simplify. To simplify it, different way to look at it, okay, you can move the x up, so the x and x cancel out. X times x to the negative 1 would be x to the 0, which is 1. Okay, x to the negative 1 times x would be x to the 0, which is 1. So that would give you integral of 1 over sine square of x. Okay, sine square of x dx. Do you remember this integral?
Cosecant. Cosecant squared.
Cosecant. That's going to be, I think, the negative cosecant. Okay.
So you flip it up, it'll be cosecant squared, and then the integral is negative cotangent.
Yeah. You change it to the, yeah, you can change it to the cosecant and okay, different way today, or just change the 1 to the sine square plus cosine square, break it, that give you, 1 plus tangent cotangent square. Okay, yes, it's going to be cosecant square, okay, square of x dx, and that would be, I think it's a negative cotan. Negative cotan of x. Okay, that's it. We have the b over here. So that gives you negative cotan of x. The other solution, you have to, if you simplify that, should give you x to the negative 1/2 cosine of x. Sometimes that would be given to the us for the second one, but it's not a big deal. If you do the other one, that give 1 over cosine square, which is going to be secant square would be tangent. It's very fixed problem. Okay, so we are not done. This is v. We have to go and find the y2. Okay, let's do the y2 here. So what's the y2 is equal to the vy1. Okay. This is it. The v is negative cotan. Okay, negative cotan of x. And the y1. Y1 is x to the negative 1/2 times the sine of x. Okay, you know that cotan is going to be sine over cosine over sine. So it would be simplified. So that would be simply, so the y2 would be negative x to the negative 1/2 cosine of x. This is the one. It's always the case. It's very famous that the solution of the specific equation will be these two. Okay. So we are not done. We know that this solution and the given one are independent. So the general solution is going to be cy1 plus cy2. That's it. We're done. If you write on this form, you accept it. You already got the y1 and the y2. You don't have to repeat it. Okay. So as you can see, it's a very nice method. So most of the time, these group of problems, they're like the second one. This is more popular for this type. Like there are a couple of them. So now you got the experience how you handle it. Okay, for future. Otherwise, all the problems are straightforward. That's it. I give you a break now. We are ready. Or challenging. Now we know how to find it. Okay. Now we are going to bring more equation and the next group of the equation. Okay, to be able to So it's very nice. Come back and we check differential equation of a second order, but when the coefficients are constant, that's the best case.
Yeah.